right here, right now. So, today's lesson, we're going to continue our discussion on troubleshooting of the variable frequency drives and try to make everything more apparent. Try to make you understand this a little bit better. Oh, look who it is.
Snow got us, man.
Snow got us.
Oro.
Snow got us.
Well, we actually about hit a hydroplanes.
That is not a lie. Let me,
we almost didn't come here
let
at
me,
all for
let me check to see if I can find a crap to give. Oh, no. Can't find it.
Hey, thank you.
Oh.
That's very nice, Mr. Weather.
I'm sorry. I apologize to you and your mother.
Well, yeah, okay. I don't think it's gonna do, you know.
We'll work on that.
I applied for a really shitty job at Comico last night.
Did you?
Co-handler.
Sounds like a pretty good job to me.
Yeah, really.
Like, where do I sign up?
I assume not the right kind of
Or like last night we went to the Mexican restaurant because I never get out, like I got home pretty early last night, early enough to go out to dinner with my family, and we went out to eat at the Mexican restaurant with my parents, and my mom and dad were sitting there, and my mom ordered a Pepsi, and the dude at the waiter was like, would Coke be okay? And I was like, yeah, I'll take some of that and bring her a Pepsi. It was crazy
I
Mexican.
sniffed really hard, but sure.
Yeah. So, and it's pretty funny.
I have a buddy who works there. Well, his brother, he called me because his brother's the one that's in charge of the hiring for the job. And he said that as long as I can get through that first process, like the computer-generated process, then his brother would at least
Take over.
interview me and probably hire me. And so he always tells me anytime there's like a job at Comico.
Yeah.
And so he called me and told me like how to get through the computer-generated process. Like you just gotta like put keywords in there so that it pulls it, tells the guy to look at it.
Yeah.
And so like on the description, one of the things like performs lockout, tagout procedures. So I just copy and pasted that onto my resume. I just looked at, he said look at the job description. He said like if the job description says you like the color red on your resume, say I like the color red. I put on the job resume that I'm good at using some crane thing. I texted him, I'm like, what is that? And he's like, I don't know.
Gee. All right, let's get this party started. Take off that unapproved outerwear.
Yes, sir.
I used to work at a Mexican restaurant where they literally did coke and smoke weed out the back door.
That's what all restaurants do. That's why my daughter will never work at a restaurant.
Yeah, no bueno.
Yeah, very no bueno.
I walked back there carrying dishes and I saw some guy go, and I was like,
That's the reason people work at restaurants is because they don't drug test.
yeah.
And they can pretty much do whatever they want. That's why you see.
Honestly,
That's why you see 40-year-old dudes working as dishwashers.
Yeah,
Because
they
their side job is selling drugs to the teenage waitresses
there.
that work there.
Uh-huh.
Like they make $8 an hour washing dishes, but they don't really care because they can make $400 off the teenage waitresses that work there.
Uh-huh.
So yeah. Anyway, are you gonna take off that sweatshirt or?
I did.
No, you didn't. I'm pretty sure you did.
Your old Elijah Plant tricks.
And I'm pretty sure you still haven't put your mask on either. Trying to give me vid.
Okay, look, the mask is on.
Right. Thank you. Anyway, today's objectives, should you choose to accept them, are to list possible AC drive failure symptoms and the causes. So today we're going to do like a cause and effect thing. This is what's going on the drive. This is what the possible causes could be and the possible remedies that could be. We're going to describe the steps you would take in troubleshooting an AC drive. We talked about the steps yesterday, right? There's 4 main steps. Make a plan.
Isolate the hardware.
Yeah. Isolate the hardware. Do what?
Check power.
Check the power and then
Fault
check for
code.
fault codes. So, describe the steps we just did. There's a bunch of more steps we're going to do in and of themselves that are beyond those first 4 steps, but we're going to do it anyway. State the results of an incorrectly setting, who wrote this thing? Of an incorrect setting on an AC drive parameter. If you have a wrong parameter, it can throw the whole thing out of whack. All right? Just one wrong parameter can screw up everything. So we're going to talk about that today too. not going to do 525 yet. We haven't started on the 525. You're still on the 40s. Also, today is going to be practice hands-on for the PowerFlex 40 for tomorrow. Muy bueno. I love this picture. It's pretty great. So, checklist. Write these down. These are kind of the checklist that you need to go through in order to properly troubleshoot an AC drive, regardless of manufacturer, regardless of brand. So, the first thing you need to do is turn it on, right? Because if you can't turn the drive on, how are you going to check the fault codes? How are you going to check the output? How are you going to check anything? So, your first indication as to how the drive is performing is if you try to turn it on and the LEDs or the screen or the display doesn't come on, chances are you got major issue, right? Some of you found that out already. The drives have a little bit of help trying to protect themselves. If you short them out or you have them wired incorrectly, they don't come on at all. They're like, nope, I'm not going to do that. So, apply AC line power to terminals L1, L2, and L3. That's the first check. If you can't get line power to L1, L2, and L3, chances are you can't turn the drive on. So the second one would be monitor the DC bus voltage on the AC drive display panel. Does anybody remember what parameter on the PowerFlex 40 is the DC bus voltage? D5. Yeah. D5. Huh?
What's 3?
3 is current.
Yeah.
Output current. So yeah, go to D05 or just D5 on the PowerFlex 40. You still have that sweatshirt on.
Oh shoot. Forgot about that.
You go to D05 on the display panel and you will be able to monitor the DC bus voltage. Why is monitoring the DC bus voltage muy importante? Yeah, if it's not producing voltage, then it's not converting the AC line power on L1, L2, and 3 into DC. That could be an indication if there's no line power coming in, or the wrong line power coming in, or you might have a problem with your rectifier. So the next thing, step number 3, is to verify the control board inputs on the AC drive display panel. On the PowerFlex 40, what is the display for checking the control board inputs? Anybody remember? Well, the actual inputs are 13 and 14, yeah. 13 and 14, D13 and D14. So any of you that have had me come and help you troubleshoot, what's the first thing I do? Go to D13 and 14. If those aren't right, you're not going to get that drive to turn on. If you have nothing there, chances are you either have a bad power supply if you're using an external power supply, or you have it wired incorrectly, or you have bad switching, bad input devices. So, step number 4, or numero cuatro, for those of you keeping score at home, is to check the speed reference on the AC drive reference panel. What is the speed reference? How do I check to see what speed reference we're using? You just said it.
Oh,
Where do we check the...
Oh, D12.
D12, yeah. D012 or D12 on the PowerFlex 40 will tell you what the speed reference is and what the reference select is for the start source. Okay, so D12, the first number, it'll have 2 numbers. One is the first number is the speed reference. The second number is the start reference. So if I had a number that looked something like this, D22, well, it wouldn't even be D, it would just be under D12. Go into D12. D12 says 22. What does that mean? Anybody remember?
2-wire.
No, you don't remember that? The first wire, the first number here is the speed reference. In the PowerFlex 40, a 2 is 0 to 10 volt analog signal. or we use a remote potentiometer or some sort of remote 0 to 10 volt analog system or signal. Like it could be a thermal
Overload.
No.
Just need that.
I'm happy that you're just awake, to be honest with you.
Actually,
You keep throwing things out. I'm like, hey, you're still awake.
Wrong, because I've never actually slept through one of your lectures. So.
That's true. I can honestly say that you've never slept through one of my lectures. Clint, on the other hand, has slept through almost every one.
What? Bro, you be sitting there like.
Throwing shade.
Yesterday he was like,
Maybe my grandpa.
Yeah. So, the first two, if I have 22, it would be 0 to 10 volt analog. If it had a 0 here, if it says 0, that's keypad. Local or keypad potentiometer or speed pot. If it has a 1 there, that is internal frequency. Okay? So if it says 2, we're looking for a 10 volt analog signal. And it can be from a lot of different things. It could be any sort of instrumentation that we're using. Us in our shop are going to use just a 2K ohm potentiometer. So let's go back to, let's say it says 0 right here and 2. The second 2 on D12 is the start source. And a 2 happens to be what? 2-wire. 2-wire start stop. That tells me that I need a fixed signal. Not a momentary signal, a fixed signal. And it needs to be on pin 2 or pin 3. If the signal is fixed on pin 2, it's going to say forward run. If it's a fixed signal on pin 3, it's going to say reverse run. That's how the drive is going to interpret that yes or no signal, that true or false signal. The way that I would confirm that is by going to D13. Going to D13. I think it's 0.
I need to get a manicure.
And I would see that. This is pin 1 on the drive. This is pin 2 on the drive. This is pin 3 on the drive. If I saw that I had this in D12 and I saw that I had this on D13, that thing should be running. It's got a run signal. It's got my enable signal on pin 1. This is enable. And it's got run reverse. It should be running in reverse up to whatever speed we have chosen. 0 would be local speed pot. Bueno? That's how you troubleshoot it. You figure out what signal you got, what you're looking for, and then you figure out what signal you have. Make it work. Get it to run. Okay? Is that clear as mud? Crystal. Set and check the speed reference on the AC drive display panel. That is what we just talked about. Control the AC drive from the operator or key display. If I can make it run from the local mode, right? If you can make that drive run on keypad, then chances are it's not the drive that's the problem. It's something external of the drive, right? It's push buttons. It's an e-stop. It's a friggin' proximity detector. It's something that's going to keep it from running. If it'll run on local mode and won't run on remote mode, something's wrong with the remote. Make sense? So check that next. When in doubt, just wipe everything out and go back to local mode. Make sure you write down all your parameters or have them stored somewhere, saved. But when in doubt, change this to 0, 0. This is parameter what? Anybody remember? And this one's what? P38. If I go to P38 and I change it to 0, and I go to P36 and change it to 0, and I hit start on the front of that drive, that thing should take off. If I have it at 24 volts on pin 1. If I have 24 volts on pin 1, it'll run. If it still won't run, you got a problem with the drive. Make sense? They're not that difficult. And you can look like a freaking wizard when they come and get you and you walk out to that drive and the first thing you check is B12 and you say, okay, I need a 2 and a 2. I got a 2 and a 2. That means I have a remote potentiometer checking the speed and I have a 2-wire start-stop. And then you check D13 and you see that you have an enable signal and you don't have a run signal. Make it a run signal. I can short it out. I can jumper it. All I have to do is get 24 volts on pin 1 or pin 2 or pin 3, and I can make that thing run. Whatever switch is controlling the signal here doesn't matter. Worst comes to worst, all I need to get is 24 volts. You can, like I said, you can look like a magician because you just made that thing run in 30 seconds because you forced it. Now, it's not the safest thing. It might not be right, but if you can make that happen, now all you have to do is get the schematic out and find out which switch is controlling signal on pin 2 or pin 3. Everybody clear? Everybody good?
Why are you on camera?
Because I'm cool. I have to record this when it's not on YouTube.
This is all recording.
Yeah.
How have you not gotten fired?
I have no idea. I have no idea. Every day I
What's that? Okay.
he just cracked a beer.
That's what I Hey, dude, no one Trevor, dude.
That's what I was just like, okay, we're doing that now.
No one Trevor, I would not have been surprised whatsoever.
Hey, I'm here.
That's what, if that's what it takes to get you.
surprised about.
Alright, number 6, verify PWM output voltage on the AC drive display panel. I haven't talked about using a meter yet, right? I haven't used a meter yet. I've troubleshooted this entire thing without a voltmeter. So how would I display, or how would I confirm the PWM output on the drive?
That would be the...
It's on the display, right? It's display like number 7.
Yeah.
So you go to D7, and it'll tell you what voltage you have on your output.
Isn't it like DL07 or something?
Yeah.
It's 4.
Is it 4?
4 is output voltage. 7 is one of the volt codes.
Oh, okay. My bad. I can't remember them all. D4 is my output voltage. D1 is my output frequency, which is the next thing we're going to talk about. If I have voltage but I don't have frequency, if it has voltage, that means the DC bus is working and the IGBTs are working, but I don't have the processor isn't working to give me frequency. Or I don't have a speed reference to give me frequency. I might have voltage sitting there, but it doesn't have a frequency. So I have a speed reference. Problem. Okay? If I'm on local and it still won't run without speed reference, chances are I have a processor problem. And then lastly, verify the AC drive setup configuration parameters. The setup configuration parameters are all the other parameters, P31 through 42.
Fetus said the
Fetus.
fetus.
Why do you still have that sweatshirt on? You're driving me nuts with it,
I
dude.
get about halfway taking it off and I forget.
Is everybody clear on all this? It makes sense, right? It's pretty intuitive. Once you know where to look, and it's not a great mystery on where to look, you just have to know where to look. Once you find out where to look, all you have to do is look. Alright, so, yesterday we talked about localize, isolate, and correct, right? What do, does anybody ever watch like wildlife adventure shows on TV?
Oh, I'm cold.
So, the cheetahs or the lions or whatever predator and predatory animal, what do? They cut the weaker gazelle out of the herd, right? They localize it. They spot which one is probably the weak link. They isolate that one. They get it out of the herd. And then they go in for the kill, right? That's the same thing you have to do. You have to isolate and localize what you're trying to fix, so you don't have to try to look at the whole thing at one shot. You try to figure out what is the weak link. If, like I said, if I have power coming into the drive, we're good there. I don't have to spend an hour and a half checking all my incoming power. If I can make the drive run on local mode, it's not the drive. So I've just located or localized where the problem probably is. It's in the control circuit. Okay, cool. Let's isolate what's in the control circuit, figure out which switches are going to control that, and then what? Correct them. Switches only have two positions, right? Open or closed. If it's an open switch, we need to get it closed. If it's a closed switch, we probably need to open it. Pretty easy. Go figure out which one it is. You can usually do it from the schematic and make it close or make it open. So, step one, validate the line voltage we just talked about and the equipment grounding. Make sure that you have good ground. Access the inverter display on the fault status. Access and study the fault sequence of events, and remove, replace, reprogram, repair as required. All of those things we just talked about.
I want a big cat.
Yeah. So, the most common drive faults. You will see these a lot. Now, the ones you guys see a lot in the shop aren't very common because you're wiring everything up from scratch and you're doing everything from scratch. Typically, you won't be doing that. Typically, that thing's been running for the last 5 years and it just all of a sudden quit running, right? So you have to go in there and figure out why. The most common are going to be overvoltages. Overvolt can happen for a lot of different reasons, okay? It could be because of amperage, what they're sending in, right? Because it wants a constant or a consistent voltage level across all three phases. If amperage starts fluctuating, it's going to trip out, overvolt. If it goes too high or goes undervolt, there's another alarm that goes undervolt. It means your bus voltage is dropped. If your bus voltage rises above allowable level, you'll get an overvolt alarm. If you have a regenerative load, so we haven't talked about stop modes yet, right? But if you have a really high inertial load that's going to keep spinning after you turn it off, it might overdrive the load, which will cause the voltage to send it back into the drive. And now all of a sudden it's seeing higher voltage than what it should. And as soon as it sees that, it's going to trip. It happens a lot of times with heavy loads. Like if you have conveyors that are going uphill, right? I got a big honking conveyor that's trying to take this big heavy load uphill. As soon as I turn the power off, that conveyor starts to slide backwards, and it regenerates that load through my drive. Okay, it basically sends voltage back into the drive. Overvolt. It shouldn't have any voltage on it. Now it's got voltage on it. Overvolt. All right. High line voltage can also cause that. Like I said, you could have a bad transformer. Ameren could be having a bad regulator day, and their regulators on their lines all of a sudden cranked it up to 500 volts. And now instead of getting 460-ish volts into your drive, you're getting 480 volts into your drive. I've had that happen. I had as much as 500 volts coming out of the power lines before. Okay, it happens. Depending on where you're at, it can happen a lot or it can happen very sporadically. This, you might need to add an isolation transformer or line reactor to get rid of. Instantaneous overcurrent. If you have an overcurrent alarm, it doesn't mean an overload condition. It means that you have a short or you have probably a bad motor. That motor just shorted out and is now drawing too much current. You can isolate that, or you can find out real quick if you put an amp clamp on it. Right? Reset the fault, put an amp clamp on it, you're going to see it almost immediately. As soon as the drive times turn on, it's going to overcurrent again because it's a direct short. It's a dead short. And that's different than an overload condition. An overload condition is the motor's being worked too hard. That could be a lot of different things. That could be the motor starting to get wore out, the bearings are going out. It could be whatever it's hooked to is starting to go out. If it's hooked to a pump, it's hooked to a conveyor, it's hooked to anything. Now it's being worked too hard. These are a little harder to troubleshoot. Okay? We talked about diode testing. Does anybody want me to go back over the diode testing? We talked about that pretty good yesterday. You guys all get that?
Positive, negative.
Positive, negative, negative, positive, yeah. It should read what it should read. It should be 0 when you're polarized correctly or you're biased correctly. It should be almost infinity or open when it is reverse biased. So hopefully everybody understands that, right? All right. That's how you check them. If you get it isolated or you get it localized to the drive and you think the drive is bad, if you don't have converter power, you don't have DC bus voltage, or you don't have output voltage, chances are it's the drive. You can isolate whether it's the IGBTs or whether it's the diodes that are coming in. Either one is going to be a bad drive. My rule was what? You remember? If it's less than what? So many horsepower, we throw it away.
Less than 100.
Less than 100 horsepower. Good job, Rainey.
Told you I
If it's
remember.
less than 100 horsepower, we throw it away. Now, obviously check with your boss first, because if you start pitching drives,
Dude, if I threw away
And,
a half horsepower motor,
not
that's bad.
motor, drive.
Drive. Dude, one time, I threw away a piece of metal in the metal bin for scrap. My boss pulled it out and was like, "You don't do that." And I was like, "Why?" It's like, "'Cause we can reuse that for something." And then he was wrong. They took it away.
Yes,
Hey, is gross income what you make before tax, right?
that is correct. Taxes and the fees that they charge you on for Social Security, all that jazz. Some companies, they take out medical insurance pre-tax, so that comes off your gross. Other things like that.
What you have to figure out.
Basically, before the government and the companies steal a bunch of money back from you. Moving on. So let's answer some questions, could we? Let's answer these questions. When troubleshooting a failed AC inverter, AC motor, or any electrical hardware, the very first electrical test. Okay, the very first electrical test will be what? What have I been saying the entire time? What do we check first? Voltage. Voltage is pressure. Voltage is fuel. If you do not have voltage, it's not going to work. Okay, everything else is subordinate. If you don't check the voltage, if you stand there for 20 minutes with your thumb firmly lodged in your keister and you haven't checked voltage yet, and you still haven't figured out why that thing isn't running, then I don't know what, I got nothing for you. Okay? If you don't, if I was running a maintenance crew and I walked out and you guys were trying to troubleshoot a drive or troubleshoot really anything, and you didn't have a voltmeter in your hand and you hadn't already checked the voltage, and it had been like 20 minutes, I would be,
What would you be, Father?
I would probably be slightly irritated.
Initial AC inverter configuration should be.
So, initial AC inverter configuration should be what? The initial AC configuration is what? Huh?
Test digital inputs.
Factory default. That's the initial AC inverter configuration. Whatever the factory default is set to. Right? That's the initial configuration. Whatever the factory set it to. It's up to you to change that configuration for your application. Right? You don't, it doesn't come preset. Let's put it that way. The first time a motor is started, what should be validated?
Rotation.
Rotation. Rotation. Bump it, jog it, on the, if you go into the PowerFlex 40 or the Allen Bradley Startup Wizard, it actually asks you to verify rotation before you even begin. Jog it, check rotation, make sure it's right. If not, what do? Swap those leads. Chances are you're going to wire it up and it's going to be wrong. Almost guaranteed. The rotation will be wrong. So then you have to go in there and you have to swap them. Don't remove it from park. To validate a motor's performance controlled by an AC inverter, which of the following will provide the most useful information? The motor performance will be most easily recognized by using a what? A digital scope meter. You won't. Most companies won't buy them for you. But the actual performance is going to best be...
I'll let them know that when my job has...
Now, in lieu of having a digital scope meter, go to the monitor, right? Go to the display on the drive. The drive display will tell you everything you need to know, right? Most companies are not going to buy you a $5,000 Fluke scope meter. It's not going to happen. If they do, they're going to keep it under lock and key, and it's going to take an act of God to get it pulled out of the boss's office.
Most likely they'll tell you no.
Yeah, and most likely they'll be like, what are you trying to do with it? Well, I want to check I just installed a new inverter and I want to check the performance.
I don't have a key.
Yeah, dude, just look at the monitor and tell me what it says. Well, it's got full voltage and I'm pretty sure it's running okay. Yeah, you're not touching that meter. Get out of here.
But I got. And then the first time someone drops it,
Yeah! No,
it'll never get out of the lock.
Yeah. Most of the time, whenever I've seen one of those be purchased, it's because the maintenance shop had extra money in the budget. So normally, if you have a budget at the beginning of the year and you have to spend it, so the first 10 months of the year, you're super, super stingy and you won't spend any money. And then like the last 2 years, or the last 2 months of the year, you're like, holy crap, we got to spend money, because if you don't use your entire budget plus a little bit, they go, well, last year you only used like $7,000 of your budget, so we're not giving you 10 grand this year. We're only going to give you 7. And so you got to spend like 11,000 so that next year you can get 11,000 in your budget. So you got like 5 grand left in your budget, and you're like, you know what Daddy needs? He needs a Fluke scope meter. Foop! I had to throw that on the tab. That's usually what happens. Keep that in mind too. If you're ever running a crew or you ever have to do budgetary stuff, you got to spend your whole budget, or they'll take it away from you.
Okay.
Not that any of you will probably ever end up running your own crews. Most of you, I foresee jobs in either the food service or custodial industries. You might end up running a custodial crew.
$5,300.
Josh thinks he's gonna be
I told you, it's like 5 grand.
Yep.
Huh?
Josh thinks he's gonna be a boss.
Josh is going to be a boss. Like, so when they mess up my Egg McMuffin and I go in there and ask for the manager, I'm going to be like, out here now! And I'm going to see a 6'5", 250-pound dude come stalking out of the back room, covered in fry grease. Yes, sir. Josh, what is up, my dog? Hey, they forgot to put the ham on my Egg McMuffin. We'll take care of that right away, sir.
It's so funny.
It's so funny. I'm sorry, Josh. I apologize.
It's okay. It's okay.
Yeah, you gotta remember to apologize to your man.
I apologize. I'm not allowed to say those kinds of things. All right, you have checked the motor connections. The AC inverter status shows run. The motor is still not turning. What could be the problem? So if it says no speed reference. It's got run signal. It wants to run. If it's not running, it's because you haven't told it how fast to run. The speed reference is at 0. Okay? So now you need to go into D12, figure out what the speed reference is, and make it go fast.
Cute.
If it's if D12, if the first number is 0, then we're looking at local. If it's 1, we're looking for an internal frequency. If it's 2, we're looking for an external 0 to 10 volt analog signal. If it's 3 I think is a 4 to 20 milli signal. 4 is preset frequency. Okay? Okay. On the PowerFlex 40, that could change for other things. So, minor AC inverter faults can be reset by activating the stop button. True or false?
True.
True. Minor fault correction. If you cannot clear it using the stop button, the best way is to do what?
Check your faults.
No. Well, yes.
Completely shut it off.
Yeah. Cycle power. If you cannot get it to clear, by just hitting the stop button, cycle the power. The power will cycle if you can cycle the power. Now, there might be shutdown procedures. If you cannot localize the drive and just shut off the drive, if you have to shut off the entire machine or the entire whole apparatus, you might have to have a shutdown procedure. Because if it's Windows-based controls or Windows-based HMIs on it, if you don't shut it down properly, bad things can happen. Okay? So make sure you do the correct shutdown procedure before you just go cycling power. It's not a,
Yes, sir.
just keep that in mind. I've had guys do that and really screw some stuff up. Major AC inverter faults require cycling line power to reset the AC inverter. What did I just say? True. Major faults, you might have to cycle the power. Can you energize a PWM AC inverter without a motor?
Yes.
Oh yeah. That inverter doesn't care if there's a motor hooked to it. Most of the time. Now, it might not run at peak performance and it might not run where it's supposed to run, but you can energize the drive without it. Okay? If the AC inverter energizes, that verifies you have voltage. True or false?
True.
False.
I mean, maybe.
If the display comes on, you might have enough voltage to turn the display on, but it might not have enough voltage to run the drive. Okay? If you do not have DC bus voltage, but the lights are still on, you still have a problem. All right? So not necessarily. When auto-tuning an AC inverter and an AC motor, what RPM do you use?
16.
Nameplate. Nominenplate.
So 9 was maybe.
Maybe. I would actually say false.
For 9?
Yeah.
No.
It doesn't verify that you have voltage. It just.
We're missing one.
Huh? What are you missing?
The first one is who's responsible for your safety.
God. All right. Nominate platen. Okay. For the AC inverter to comply with NEC Article 430, what motor nameplate data must be configured into the AC inverter?
The voltage.
FLC, right? That comes directly out of National Electrical Code, Article 430.250 or 249, 248, depending on if it's a single-phase or three-phase motor, right? You need full load current. Also, you can look in the Uglies book. Use AC inverter control and speed inputs can be monitored using the AC inverter monitor display.
True.
True. The inputs can all be monitored there as a binary, right? Your binary. Motor overload fault indicates a problem where? If I'm getting an overload fault, what is it?
Drive.
The motor or the load? Motor or the load. The only thing that can overload the drive is the motor or the load that's on the motor. Like I said, most of the time it's not the motor that has the problem. It's whatever's hooked to the motor. The pump, the conveyor, the flywheel, the fan. Those sorts of things are what go out. The motor, if it's treated nicely, will last a long time. Don't always assume it's the motor. Motor T lead short to equipment ground is what type of fault?
Ground fault.
Ground fault.
I'm on it today, dude. I think
You are on it today.
2.5 questions.
Must have had his Wheaties.
Yeah, I know. High line voltage. What type of fault will the AC inverter indicate if you have high AC line incoming line voltage?
Overvolt.
Overvolt. Not just incoming, it could be on the T leads too. The AC inverter trips in overload while accelerating. What should you do, or what could you do to correct this? So if I'm accelerating and I'm getting an overload alarm while I'm accelerating, that means I'm drawing too many amps trying to get this motor to start.
Decrease acceleration.
Yeah, decrease the, no.
Wait, what?
Increase the acceleration time. Make it take longer, right? Increase that ramp.
Gotcha.
Not decrease it. If you decrease it, it's going to draw more current.
I see what you're saying. But I also see what Justin was saying.
You want to decrease the amount of current it draws, yes, but in order to do that, you have to increase the time. That's that ramp we were talking about. Next week, for your listening and viewing pleasure, we are going to discuss actually calculating acceleration and deceleration times, what you can and can't get away with, how much it takes to accelerate specific loads, how to calculate the actual load inertia, let's call it.
What was that one we did where it would like jump it up to like 60 and then bring it back down and accelerate?
Kickstart. Kickstart. Are you a Rangan material?
No.
Absolutely not. Any questions, comments, or concerns? Yes, no, maybe? You done taking selfies?
I want to take a selfie.
Okay.